This one I think might be a little easier. So let's see who's still on. So we have a cyclic quadrilateral. The diagonals are perpendicular. So F is on BC. Yeah, this one looks like it should be a little easier. So okay, so this intersects at point E. And FG, we draw parallel to BD. Oh, this looks kind of interesting. Okay, so I don't know if I've seen this configuration before like this. So this is G. Then we project E onto CD. Okay, and that's P. And then F onto DA. And that's Q. And G onto AB is R. Oh, and it's interesting that we have all these concurrencies. So, and then we want to show QF bisects PQR. Okay, so that looks cool. So first of all, is it obvious that these concur and these concur?
If we just have E and F being the midpoints, then we can just use Mikhail point, but no, it doesn't have. I mean, no.
Yeah, they're not necessarily midpoints.
Yeah, I know.
Yeah. So we project E, F, and G.
Q.
All right.
This looks kind of like blanket theorem.
Blanchett's theorem, yeah.
But that one was a triangle. We have a cyclic quadrilateral here.
Yeah, it was, so yeah, maybe we could extend A, B, and C, D, and
yeah.
I mean, yeah, we want to show we have a harmonic bundle, right? So let's do that. Let's draw some intersections. So if we want to show that this is an angle bisector, then let's just draw this and this, and this and this, and shrink this a little bit. We want to draw those 2 points, and So yeah, QF doesn't pass through J, but so we want to show that we have a harmonic bun.
Maybe it is useful that DE, actually there is no D, FEG and PQR are concyclic.
Okay. So FEG, PQR are all lie in a circle.
Yeah.
Okay, that does look easier. So then we can project onto the circle maybe. So it's the same as showing that this is harmonic. Sorry, let me make it look like it did before. Yeah, projecting on, if that's cyclic, yeah, projecting onto the circle seems like a logical idea. So let's see, maybe we should draw the center of the circle. Oh,
Just a second. By the way, if we can prove that QF and DE and AP are cyclic, I mean are concurrent, that finishes up the problem.
UF, DE, and AP.
No, DR, sorry.
Oh,
DR.
is that by Briancon's theorem?
But it didn't. Yeah, but we don't know that this one is altitude. Yeah, sorry.
How does it finish the problem?
No. Sorry, I thought we don't know that it's the altitude. Yeah.
Oh, okay. And yeah, so we can easily prove that F, E, P, G, and R are on the circle. However, for point Q, it isn't as obvious. So maybe we should start with proving that Q lies on the circle. And then after that, we would just need to show that FR is equal to FP.
Yeah.
So kind of two-part solution.
Okay. So maybe I could delete K and J. I was thinking about, yeah, maybe K and J aren't so useful.
Actually, we can easily angle trace that FR is equal to FP.
Oh, really?
Yeah.
All right.
So we just need to show that Q lies on the circle.
All right. All right. 1 second, I'll be right back. Sorry.
So right now we want to prove that FHQ is collinear.
Could you repeat?
We want to prove that HFQ are collinear right now.
Not sure if that helps.
No, I'm asking what we are doing right now.
We want to prove that Q lies on the circle. We know for every other point except Q.
Oh, okay.
Because yeah, angle ERG is EFG is EPG is 90. So we just have to show EQG is 90. And then Stefan says that once you do that, it's not hard to solve the problem.
Complete the rectangle EFG.
Oh, okay, EFG.
Complete the rectangle EFG,
Okay.
like which is the intersection of AD and the circle.
Sorry, say it one more time.
Take the intersection AD and the circle, the small circle.
Oh, AD and the circle.
Yes.
This point.
We don't know. Like we will prove EFGJ is a rectangle, which is obvious because the diagonals are perpendicular.
Okay.
And then obviously JQF equals 90. Like, sorry, what?
So Q is defined as a projection of F. Okay, so
Like hide the circle, yes. Now we know ERFGJ cyclic.
okay. I think I see
Now,
what you're saying. Yeah.
Yeah, now, yeah, it is obvious that Q lies in the circle.
Okay, so that proves that Q lies on the circle. Because yeah, we draw this point, which makes a rectangle. And then once we have this point, and it's easy to show that lies on AD, then it's just, yeah, an easy angle chase. Okay. So, all right. So this one we solve quickly. All right. So
Will this lead?
we'll type it up. So angle ERG is EFG is EPG is 90. And so that implies ERPFG is cyclic. Then we're going to want to let J be the point so that EFGJ is a rectangle. Then we're first going to want to show J lies on AP. And that should be easy by the parallels, I would assume. So basically, we know that J would lie on AD, assuming it's by ratios, right? Because
the diagonals are perpendicular.
Yeah.
So basically, I mean, we could instead let J be we could draw the parallel from E to FG and let it meet AD at J. And then we want to show DJ over DA is DG over DC. But that's true because DJ over JA is BE over EA, which is BF over FC, which is CG. Or maybe there's just a way of thinking about it using a homothency. I don't know.
Yes. Just thought about it.
Just what?
Yeah. So I thought about solution with homothency, but it's a little bit different. We can define like midpoints, let's say S and T.
Okay, I'm just going to finish writing up the solution this way. So
Yeah.
let the parallel through E to FG. Let the parallel through E to FG meet AD at J. And then we have DJ over JA. So DJ over JA is equal to AE over EB, which is equal to CF over FB, which is equal to CG over GD. Or I think I mixed up something. So DJ over JA, this would be BE over AE. BE over AE, which is BF over FC, which is DG over GC. And that means that JG is parallel to EF. Which means that JGFE is a rectangle. And that means that J lies on the circle. And then from there, it's easy to show that Q lies on the circle. So because angle FQJ equals angle FGJ, EJ equals 90. So circle. And then I'll do Stefan's angle chase. And that should solve the problem. So angle FRP equals FGC, which is BDC, which is BAC, which is BEF, which is RPF. And okay, so that implies that FR equals FP. I mean, that by itself is enough. And in fact, we could just say, we could just say angle FQP equals in fact, I wonder if we could just skip this step. So in fact, we can get rid of, if we really wanted, we could get rid of R. And instead of RFP, we could say it's RFP. Instead of RPF, we could say RQF. Wait, is that right? Wait, FQ.
Looks good.
Okay. All right. Okay, so I will move on to the next one. So we have an hour left. Oh, this is like a conditional statement. Tell you what, let me do, so Lenardi, I don't know if you're still on, but Lenardi sent me a problem. Oh, Lenardi's is like a specific condition, so I don't think I'm going to do it right now. So we could do this, we could do this. What else? Okay, let's try this one. This is a, well, So we could do one with a 60-degree angle, or we could do, oh, I don't think this one is really a conditional problem. So, so we have another cyclic quadrilateral, and it looks kind of similar. So F is the intersection of AC and BD. And BA and CD need a E. So why don't I draw E first? So this will be E, this will be F. Then we project F onto A, B, and CD. Okay. So basically, those points will be corresponding points in those two similar triangles. So this would be G and H, and they correspond to each other. And M and N are the midpoints of B, C, and EF. Okay. So this is M, and this is N. The circumcircle of M and G and M and H. So we want to see where they meet CF. So BF and CF. So, so this would be P. And this would be Q. We want to show PQ is parallel to BC. Okay. All right. Looks nice.
Does it actually look parallel?
What?
It doesn't look really parallel.
Oh yeah, PQ to BC. So I was thinking AB, so I must have done something wrong. So F is the intersection of AC and BD. BA, yeah, because where do we use point E? Oh, the midpoints of BC. Oh, N is the midpoint of EF, not AB. So that's where I messed up. So, this should be N. And so we draw the circumcircle of MNG and MNH. And they almost look like they're the same size. Maybe they are. So let's see. So MNG meets it at P. This looks better. And this meets it at Q. Okay.
Yeah,
Then-
that is.
So we probably want to show that like F or BP over BF is CQ over QF or something like that. I could check to see if these are the same size. It looks like they are.
And also, like, P and Q seem to be the midpoints.
Okay, they look like they're the midpoints, right?
Yeah.
Yeah. So
If we prove that they are the midpoint, then we are done.
and that solves the problem. Yeah.
Yeah.
It's the same as saying that PM is parallel to AC. So really, we don't need the other circle. I'm almost afraid to hide it because when I did that for the last problem, I forgot what I did before. But we'll just remember. We want to show PM is parallel to AC. And let's see how we can do that. It's probably worth drawing the center of the circle, and we can call it O. And I wonder if O lies on MN. No, it doesn't.
MN is the Gauss length, so can help.
So it would pass through.
The
Well,
midpoint of OG.
yes. Let me check that these circles are the same size. I guess I could do it this way. But pretty sure it's true. Yeah. Okay. So the fact that they're the same size is probably useful somehow.
I think I've solved the problem.
Okay.
One part we need to show is that MN is the perpendicular bisector of GH.
Okay.
And if we have that, we can angle chase the finish.
Okay.
So obviously NG and NH are equal.
MG and MH.
NG and NH, because we have 90-degree angles and N is the midpoint of diameter actually.
Wait a sec. So
N is the
NG,
sector of-
NG and NH. Yeah. Yes.
So we need to show that MG and MH are equal.
Mm-hmm.
And we can show that with a pair of congruent triangles. And in fact, triangles MQH and GPM are congruent.
MQH and GPM.
Yeah. Well, if you define P and Q as the midpoints.
Okay. So first we define P and Q as the midpoints. And then so MP is half of FC, which is QH, and MQ is half of BF, which is PG. So we know that those two sides are pairs of sides are equal, right?
Yeah, and you can angle chase the angle
Okay.
for the congruence. So because of that, we have that MN is the perpendicular bisector of GH.
Mm-hmm.
And now we can just angle chase that GPMN is cyclic. So
Okay.
you would angle PMB.
I'll call them P prime and Q prime.
Sure. So angle P prime MB
Mm-hmm.
is equal to ACB.
ACB. Mm-hmm.
Wait, maybe I got the wrong angle.
That's right.
Actually, we look at the angle BG P prime. So angle BG P prime, it is equal to ABD.
So I guess it's weird. So you're trying to show that GP prime MN is cyclic, but we don't. But B doesn't lie on that. But are you still using B as part of the proof?
Oh, then maybe my angle trace is just wrong.
That's all right. But
Yeah, but probably we can angle trace
there's probably a way to do
using
it.
this MN perpendicular.
Because MN and I are collinear, so like we could try to show angle IM Q prime is angle NH Q prime.
Wait, is NQ perpendicular to FH? You said that?
Is what? NQ prime perpendicular to FH?
Yeah, I think you said that, or I'm hallucinating.
No.
But it looks like it's true. I don't know why.
Yeah, that looks strange.
Interesting.
No, actually, it is true. Because Q prime F is Q prime H and NF is NH.
Okay.
Yeah, and NMG is
Maybe that'll help us solve it.
NMG. NMG and MH. So we have NG. If we prove that NMG is congruent to NMQ, no, NMH, they are congruent, then this will NMG and NMH.
So NGP prime is NGF minus P prime GF. Are P prime GF and Q prime FH similar?
Just so NP prime BGF. EDF.
Yes.
EDF.
Okay, I think I might have solved it. So we want to do an angle chase to show that this is cyclic. And that's the same as showing an angle GNM is okay, now I'm getting
So to prove that N, M, P prime, and G cyclic, we need to prove that EDF is similar to NP, P prime M.
GNM. Sorry, I think Stefan just gave a solution. So I'm gonna
Yeah, I wrote the angle chase.
okay. And all the whoops, sorry, I didn't mean to do that. But the
Yeah, the angle chase is really long.
but P should basically be P prime in that angle chase, right?
Yeah.
Okay. So let me just write it out. Okay. All right. Let's see how this looks. Oh, that came out nice. Okay, so let P prime and Q prime be the midpoints of BF and CF. And then we have GNM equals GEH. That's because it's half of GNH, which is GEH, because that's cyclic. And that would be equals AED, which is 180 minus ABC minus DCB. Boy, ABC and BCB almost look like they add up to more than 180. So maybe it's, let's see, 180 minus.
Oh, the problem is that my diagram is different.
Oh, it looks different. Okay. So AED, it would be 180 minus this, which would be BCB and ABC. So it would be 180 minus so I think it would be like a negative of this maybe.
It would work if we use directed angles.
Okay.
Maybe.
So ABC is FBC plus FCB. Wait, so this is saying ABC is, so FBC plus FCB minus 2 ABD. And then, okay, so you're using that AFB is P prime MF. Wait, AFB is P prime MF. think this might be, is AFB is AQ prime M, which is MP prime F. I think some of this might be a little, okay, but I'll just say,
We'll try to fix it.
okay. Maybe I'll just say by an angle chase similar to the below, so we could try another problem. What do you think?
Yes, yes.
Okay.
Less work for me.
Yeah. GP prime. So by an angle chase similar to the below, GP prime MN is cyclic. Yeah. I just want to have fun on these sessions, you know, if we know that there's a way to angle chase it,
Yeah.
we'll just say that. That's weird. The P prime equals P looks weird.
Yeah.
I don't know why the P looks so strange, but oh, well.
You
No
have
problem,
a dollar
we'll watch
sign.
Oh, that's why. Yeah. Okay. So the P prime equals P, Q prime equals Q. And then PQ. So then MP prime G or those were congruent, right? MP prime G and MQ prime H.
And where then?
By side angle side congruence. All right, let's move on to another problem. So yeah, the angle, you have to do some angle chasing, but it's like, should be easy enough.
Yeah. Can we do an IMO problem, because like China TST problem? Okay, as you wish.
Okay, yeah, you want to put the IMO problem in the chat?
No, any IMO problem, because China TST like questions are more like straightforward, and not like straightforward. I mean, like they involve calculations a lot.
Okay, yeah, I agree. Like more angle chasing. So you
You
want
have
to
a
do?
suggestion?
Okay.
Yusuf, do you have a suggestion on the IMO problem?
Just a second.
Well, obviously, we would look at the IMO shortlist. Doesn't really matter to be really on the IMO.
I have a suggestion, but I forgot which one problem is it. Oh,
Okay.
yes. Just a second. I'll check which problem was it.
Okay.
2015 G5
2015 G5. This one.
SL.
All right.
Yeah.
Don't look at whatever he wrote. I trust you guys aren't looking, but yeah.
That's Ivan Chen.
Yeah, it looks like Evan Chen typed that up. All right, so all right. So maximize it. So we have a triangle. And then we draw the midpoints of the sides. And then E, F, and G. It's interesting that they don't say E. So D, F, and G. Don't know why they don't like E, but okay. Can we draw a circle through C and tangent to AB at D? Okay, so so we'd want to do this.
Point C should be on the top in this problem.
What?
Point C should be on the top.
Okay. So we would have this circle. So, and then it meets AF. Wait, D is the midpoint of AB. F is the midpoint of AC. Circle passing through C and tangent to AB at D. Meets okay. It's just saying that it. I was wondering why I would say AF and not AC, but it's okay. So that's H, and it meets BG, but it has to intersect the segment BG, is what I think it's saying. So like that. At I, and then so that's I, and then the points H prime and I prime, so you reflect them about F and G. Oh, this looks nice. So is that right? And then H prime I prime meets CD at CD and FG. That's kind of interesting. So Q and M. Where H prime I meets CD and FG. So I wonder if
what's G for?
G is the midpoint of AB.
No.
Oh,
Oh, yes, sorry.
it's all right. CM meets the circle of P. And we want to show that CQ equals QP. Okay.
CM. So we can say that a circle passing through P and Q with center C. We want to prove that, right?
We want to show there's a circle, yeah, through C and P with center Q.
No, with center. Same thing. Yeah.
Problem.
Yeah.
I wonder if is PQ. No, I don't think PQ is parallel to AB or GEO. So
No.
So our M, and I don't think MI and H are linear than that. That wouldn't make sense. So, okay.
So.
But yeah, this looks like a good problem. So basically, I wonder if it's worth drawing this. So this isn't an angle bisector, but
See.
yeah, it's a good problem. So let's see. What can we find? Is MPH prime F cyclic? Let's see. I doubt it. Oh, it looks like it is.
Okay.
Just guessed. So why would that be? So then MP I prime G would also be cyclic. It's like a McKell point. We'd have all these cyclic quads. And then I think this would also be cyclic, actually. All right, looks like Yusuf is back. All right.
You found many. You found many cyclic quadrilaterals.
Oh yeah, a lot of cyclic quadrilaterals. Let's see. In
Did you
fact,
prove that? Did you prove that? Because I disconnected for a while.
no, I didn't prove. I didn't prove that they're cyclic. I just noticed it. Wonder if this is also cyclic. No. Or if there's anything special about this circle, which I don't think there is. So yeah, I wonder if there's anything like special about this point. I'm just kind of cheating here, but oops, sorry. Maybe not that point, maybe this point. It almost looks like H prime J is tangent. Maybe that's true. No.
So you're trying to prove that they are cyclic by a power point.
I'm trying to see how I can show this angle equals this angle. Like I'm trying to see, even if I knew everything was cyclic, how would I solve the problem?
So
Maybe we have some kind of spiral similarity. So PIH PIH and Pi prime H prime, yeah, are those similar? Yeah, Pi prime H is similar to P, right? Those should be similar. Pi prime H prime and PIH. So that's probably helpful because then I wonder if we have like maybe these are orthogonal. Let's see.
Would inversion at center P help?
What?
Inversion at P.
Oh, did you say bashing at P?
No, inversion.
Yeah,
Inversion.
inversion at P. Oh, sorry. So yeah, if you can find a good circle, let me know. Do inversion. Or maybe we just want to invert about an arbitrary circle.
So inversion will make, but we don't know that they are cyclic. We can't assume that.
Yeah,
We must prove that they are cyclic, and then we can think about that.
and then we can invert.
Yeah.
We want to
Well,
use
I know how to prove the cyclic thing.
Oh, we know how to prove it?
I know how to prove it.
Okay.
You can use power of a point at B and A.
E and A.
DNA.
So BD squared is BI times BC, and AD squared is AH times AC.
Okay.
Yeah.
And those two are equal because of the midpoint. And also BI is CI prime. So you can by power of a point get that BI prime H prime A is.
Oh, that's another cyclic quadrilateral. BI prime H prime A.
Yeah, but that is basically equivalent to GI prime H prime F.
Okay. Because they're parallel. Yeah.
Yeah, and you can use like some power of a point to prove that P is the Mikhail point.
Okay. And yeah. By symmetry, I guess. Well, yeah, these concur.
That is by radical axis. G and F lie on the radical axis of those two circles.
Okay.
So that's why.
I wonder if MI. So it's probably, there's probably some radical axis thing that shows that these occur.
So, as Stefan said, we can prove all the quadrilaterals that we had are cyclic by power of point. He was right. So
Yeah, we can prove all
of them, it's possible to prove by power of point. as
most
he
of
said.
them are actually just by Mikhail point. But yeah.
Yeah.
Now we can target the points B, A, I, H, right?
Or Um, so since we have a lot of circles, can you just draw a circle centered at C or Q or P? Like,
I mean, there's this circle right here. I don't know if it passes through any other point though. That's useful. So the power of Q with respect to this circle is CQ times QD. Maybe we could somehow show that's PQ times QD. Well, wait a second. What if I drew this and I let it intersect this circle at a point? I wonder if K, basically, I think we want to show that Km equals Kg. I don't think that's actually true. Never mind.
Now the problem looks simple because
Sorry, your microphone is breaking up a little bit.
okay, basically we can forget the point BCIH, sorry, BAIH. We can consider everything in terms of.
Okay, so we have BAIH.
We can consider everything in terms of GFH prime I prime, right?
Okay.
And then Q prime would be the intersection of I prime H prime and the midpoint of GF and C, right?
The midpoint, sorry, hold on a second. The midpoint of GF and C. Okay, so the Q prime we would let be the intersection of CK and I prime H prime.
Yes.
Okay.
So this looks simple, right? We have a cyclic quad and some equal point and this intersects.
Okay. Yeah, it looks because we can simplify the problem. Okay, so we have this cyclic quad where FG is the diameter, and we just intersect CK and I prime H prime, and then we have the McKell point of it. So KP I think is perpendicular to CM, right?
Yes,
Brocard. And we want to show that CQ. Oh, so if this is a right angle, that's just the same as showing that this is the midpoint of CK, right?
But that is not true.
Oh, it's not true?
PK is not perpendicular to CM. That is because K is not the center of circle G, I prime, H prime, F.
Oh, okay. So K is the midpoint of FG though. It's just not the center of the circle, right?
so,
Yeah.
I wonder if we can like
So maybe we
project.
can draw the center and somehow use it.
But this won't help us. No. So since we want to prove that CQ is equal to QP, can't we just use like some like can we just try to project them? If we try to project these like points and we prove that no, this won't help.
I think it's interesting that in a special case where K is the center, then the proof is probably easy. So maybe we could, I don't know if we can let L be the center, and then we know that that's perpendicular, and maybe we could take the midpoint. Let's see. We take the
Can you
midpoint.
intersect HI? Can you intersect HI and AB or sorry?
HI with what?
AB. Where is HI for that? Yes.
AB. For AD. So this point?
Yeah.
Okay.
Then
Yeah, this is an interesting, this is a really cool problem. So yeah.
where did Q go?
Q, well, I guess it's right there. We could just call it
Yeah, I saw it.
know why we called it Q prime, because we know that these are linear. We could just call it. But, so I wonder if we have a spiral similarity that takes pi from h prime to pih. I wonder what it takes Q2 and C2. Yeah, it's tricky.
So a circle centered at C, and can you make the intersection of P and H prime? PH
What?
prime, intersection of P and H prime, and C and I prime. Can you do that intersection? Let it to be something. No, H prime and H prime P and C I prime.
Oh, okay.
Yes. So if we consider a circle centered at C, no.
Trying to use Ricard's theorem.
Yeah.
But we haven't drawn IP, that's the only thing. For I prime P.
I feel like the finishing is just angle change because we have too many cyclic chord and CQ is the median, of course, of C I prime H prime.
Oh, it's a symmedian. I didn't know. How do you? Oh, because this is cyclic and K is midpoint. Oh, okay. So then it probably is angle chasing.
Yeah, this.
Okay. So let's think about that. Yeah, I missed that it was the median. So we just need to show, let's think about that. We want to show angle SCP, or sorry, we want to show QCP is QPC. QCP is QCI prime plus I prime CP. And Q
Can you do a circle centered at Q? Yeah, take them with inversion at the with respect to the circle. Help.
Do you want me to invert? Oh, wait, I didn't notice. So it's interesting that these points, I don't know if, maybe this is just obvious from how I constructed things. But so PL and CK are okay. There, yeah, I think it's trivial that those are going to intersect on that circle. Okay, but basically you just want to invert everything about that. We could. I'm a little afraid to do it. We only have a few minutes, or actually we're out of time. But yeah. Yeah, it's an interesting idea. Unfortunately, we're out of time. So, but I like what Coffee said about this being the median, and then maybe we could angle chase. We'd have to figure out how to get QPC. So I'm not exactly sure how we would do that. Or if there's an obvious way to do that. But I'll keep working on this after the session. So I think I'm going to stop here. So thanks everyone for participating and for the problems you proposed. This is a lot of fun. So for everyone watching, if you want to join us in the future, feel free to email me at mgreenvito1@gmail.com. We meet every Sunday at 8 a.m. US Central Time. So thanks again. Have a great day.